Good morning all. I am Dr. Vemula Himamaheswara Rao, Assistant Professor of Physics, Department of Freshman Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Welcome to the lecture series, Atomic and Molecular Spectroscopy. Today we are going to discuss Sommerfeld Relativistic atom. The contents of this presentation are fine structure, elliptical orbits, allowed elliptical orbits, energy of electron in an elliptical orbit, relativistic correction, limitations of Sommerfeld theory, and then references. Fine structure. So, in earlier lectures, we already discussed that whenever hydrogen gas is heated to higher temperatures, it emits light at different wavelengths, particularly in visible region. It emits light of wavelength. Here, all these are the light emitted in that particular wavelengths when observed by using spectroscope of lower resolutions. So here, this is the wavelength regarding no, this is the line, a spectral line regarding the wavelength 343.6 nanometer, and this is the light emitted by at wavelength 410.2 nanometer. This is at wavelength 434.1 nanometer. This is at 486.1 nanometer. This is at wavelength 656.1 nanometer. So these spectral lines are observed in visible region. These are called spectral lines, and also whenever we see in the some other spectroscopes, we can see light emission in the EV region and IR region also. Those are identified as different series, and this is Balmer series particularly, and there are series like Lyman series, Passion, Bracket, and Fund series also. So all these are spectral lines emitted by hydrogen gas when it is heated to higher temperatures. So the origin for emission of these spectral lines is already explained in our earlier lectures. So please go through those lectures, particularly the lecture titled Bohr's atomic model. So it is very important to remember all those things, whatever we discussed in our earlier lecture here. So these are the lines only observed only when seen under spectroscopes of low resolving power. But when the light emitted by the hydrogen gas observed by high resolving power spectroscopes, can see several group of several spectral lines around these particular lines again. For example, in the visible region, these particular lines are again consisting of several lines. For example, this blue line at 434.1 nanometer again can be seen under spectroscope of high resolution. There are several lines which are very close together. This single it is appearing as single line under low resolving power, but when seen under high resolving power microscope spectroscope, this is not single line. It is a group of several spectral lines which are very close together. So see here, the single line is only a group of spectral lines like this. So it is came when we see these emission light emission under spectroscope of high resolution. So this type of structure is called fine structure of spectral lines. Fine structure of spectral lines. But in our earlier lecture, particularly in the Bohr's atomic model, we discussed that these lines, the origin for the emission of these spectral lines is due to the existence of orbitals. Electrons are revolving around certain orbits, particular orbits, and again it is they are depending on the quantum number. We are assigning quantum number for these particular circular orbits. Electrons are revolving in certain orbits, certain particular orbits around the nucleus. If it is the nucleus, there are certain orbits according to Bohr's atomic model. So these are assigned quantum number for this orbit. You can assume quantum number, principal quantum number n equal to 1. Here it is n equal to 2, and here it is n equal to 3. In the same way, we can assume several number of orbits around the nucleus. So electron must revolve around only in this particular orbits according to Bohr's theory. And again, when electron is revolving only in these particular orbits, they also having particular energy values. So according to that Bohr's atomic theory, we are observing these particular emission lines due to the transition of electron from higher energy levels to different lower energy levels. But when we are seeing spectral lines, individual spectral line, this single line again is a combination of several spectral lines which are very close together, means there must be several lines of uh, small difference, several orbits. For example, for n equal to 1, it is having particular energy value, but with small energy change, energy difference, there must be several lines according to for corresponding to these uh, lines, these spectral lines, for particularly this blue line. Not only this blue line, all these lines, not only even in the visible region, maybe in the UV and IR, we are seeing several group of several spectral lines for each single line. So we can explain the origin of these spectral lines by using the by assuming that there are several orbits also. For every single orbit, there are several orbits. For every energy value, there are nearly with a small change of radius of circular orbit, there must be several orbits nearby this orbit. So then only we can explain these fine structure of spectral lines. So this type of existing of these lines with a small separation are called fine structure. So this fine structure can be explained only when we consider there are existing several orbits with a small change of radius. So, but according to Bohr's theory, only one electron orbit is possible for one principal quantum number for each value of n. So obviously, we cannot discuss. Bohr's theory could not explain the fine structure of spectral lines. So in the year 1915, Arnold Sommerfeld, a German physicist, extended the Bohr's theory by considering the idea of elliptical electronic orbits. according to Bohr's theory, electrons revolve around the circular orbits. But scientist Sommerfeld proposed and extended the Bohr's theory by considering there are also including circular orbits, elliptical electronic orbits also exhibit. So, by considering elliptical orbits and also along with the consideration of the relativistic variation of the electron mass, Sommerfeld tried to explain the fine structure of spectral lines. So, the atom proposed by Sommerfeld is therefore called Sommerfeld Relativistic Atom Model. So, let us discuss this relativistic atom model proposed by Sommerfeld. So, according to Sommerfeld, in general, as the electron is revolving in the orbit due to the influence of central force, it must be revolve around the elliptical orbits. Therefore, it is postulated that in an atom, an electron moves in an elliptical orbit with a nucleus located at any of the two foci. There are two focuses for any ellipse. So, elliptical orbit maybe if you are assuming a nucleus of the atom is located at a foci here positive charge nucleus is located. So, if the electron is revolving around this elliptical orbit with velocity v, then in general, as per the Bohr's theory, if the electron is revolving around the circular orbit, in order to describe the electron motion, we need only one coordinate. But when the electron is revolving around the elliptical orbit, according to the Sommerfeld theory, we need minimum two coordinates. Let us assume that one coordinate is radius vector r and the other coordinate azimuthal angle phi. One is this is the radius vector and second one phi is the azimuthal angle. So two coordinates are required to describe the motion of the electron. So in general, momentum of the electron can be resolved into two components, PR. As we are taking two coordinates, we can describe the momentum in two components. One is PR along the radius vector, and the second one is P phi at right angles to radius vector. So Sommerfeld assumed that the generalized condition. So except these two coordinates remaining general conditions are same for elliptical orbits also as per the circular orbits. So we can take uh, momentum PR dr as nr h and p phi d phi equal to n by h, as nr is the radial quantum number and n phi is the azimuthal quantum number. And here let us assume the equation number 1. This is the equation number 2. In the earlier lecture, Bohr's atomic model, there is only one quantum number n, that is the principal quantum number. But here the principal quantum number is distributed into two components. One is radial quantum number and the second one is azimuthal quantum number. So the total value, the addition of these two quantum numbers, nr plus n phi, must be equal to the n, that is the principal quantum number. So let this equation also to be equation number 3. So here let us find the allowed elliptical orbits. So according to classical dynamics, as the electron is moving around the uh, elliptical orbit, the angular momentum p5 must be constant so that we can find integration of the phi pi d pi. Phi pi, that means it must be equal to, according to earlier equation, d phi equal to n pi h, and again for integration p phi into 2 pi, as we are doing for elliptical orbit, phi pi into 2 pi equal to n pi h. So let this equation number phi pi we can get n pi h by 2 pi. Let this equation number 4. We are finding the allowed elliptical orbits. So this is the angular momentum. So let us find the radial momentum pr. That means mass into velocity. Mass into velocity means we can take it as dr by dt. Okay, so dr by dt can be taken like this also, dr by d phi into d pi by dt. And again here, d pi by dt is the rate of change of angular displacement, and it can be taken as p phi by mr square. So here we can cancel m, and we are writing this expression as p phi by r square into dr by d phi. And now integrate this pr for pr. So throughout the elliptical orbit, so integral pr dr over ellipse is equal to the same expression here. This must be equal to nrh according to the equation number 1. Okay, so here this equation again can be written like this: 1 by r dr by d phi whole square into d pi, that is equal to nrh. And to evaluate this equation, let us simplify this term 1 by r into dr by d phi in terms of phi. For that, we need to take an expression relating between radius vector and eccentricity of the ellipse. So this is the relation 1 by r equal to 1 by e cos theta by a into 1 minus e whole square. So let us differentiate in here. R is the radius vector, E is the eccentricity of the ellipse, and A is the semi major axis, length of the semi major axis. So on differentiating this equation, so let us take the equation number as 5. This equation number 5. So differentiate the equation number 5. We are getting like this: 1 by r square dr by d phi equal to e sin phi by a into 1 minus e square. So now here, let this equation number 6, divide the equation number 6 by equation number 5. We are getting this. That means after dividing this equation with the equation number 5, so the denominator term cancels, and then we are getting 1 by r dr by d phi equal to e sin phi by 1 plus e cos phi. So this is the equation number 7. Now substitute the equation number 7 for 1 by r dr by d phi in the equation number here this equation. In this equation, we are saying like this: p pi into integral e sin phi by 1 plus e cos phi, instead of 1 pi 1 by r dr by d phi, we are substituting this value e sin phi by 1 plus e cos phi, and then whole square d phi equal to nr h. Squaring e square sin square phi, you can write this equation expression like this: e square sin square phi by 1 plus e cos phi whole square d phi equal to nr h. And again, on integrating this expression, we are going to get like this: 2 pi into p phi square root of 1 minus e square minus 2 pi p phi equal to nrh. So, as per the earlier equation, p pi can be taken as like this. We already in the earlier equation, this is the equation 3. So, substitute this value of p pi in our present expression. So after substituting here 2 pi by square root of 1 minus e square into p pi means n pi h by 2 pi minus 2 pi into p pi means n pi h by 2 pi equal to nrh. nrh. Here I'm cancelling 2 pi here also, and h on both sides of the equation. Finally, here we are getting n pi square root of 1 minus e square minus n phi equal to nr. And again, taking this n pi into the right side, n phi pi square root of 1 minus e square equal to nr plus n phi. And again, you can solve this simple expression into 1 minus e square, taking into the right side, and taking this term into the left side, it becomes n phi by nr plus n phi. That's what we are writing here. And again, nr plus n phi means total principal quantum number n. So on squaring on both sides, we are getting this expression: 1 minus e square equal to n phi square by n square. But for the ellipse, the relation is that 1 minus e square equal to b square by a square, whereas a and b are the lengths of the semi-major and semi-minor axis. A is the length of the semi-major axis and b is the length of the semi-minor axis. Here A and it is B. So on comparing these two equations, we can write as n phi by n equal to b by a. N phi is the azimuthal quantum number and n is the principal quantum number. So the ratio between azimuthal quantum number and principal quantum number must be equal to the ratio between the semi-minor axis and semi-major axis. So this is the condition for allowed elliptical orbits. This is the condition for allowed elliptical orbits. So that means allowed elliptical orbits are those for which the ratio of minor to major axis is in the ratio of n phi by n. So a series of elliptical orbits of different eccentricities are thus allowed for values of n phi from n minus 1, n minus 2, n minus 3, etc. up to 1. N phi can have values from n minus 1 to n minus 1, and we can include n also. It can be equal to n also, the principal quantum number. The time the value of nr is equal to 0. And the orbit is circular for n pi equal to n. Whenever n pi is equal to n, the orbit becomes circular. It is not more ellipse. So, however, n pi cannot assume the value of 0. We cannot assume the value of n pi at 0, because whenever it becomes 0 means the electron must oscillate along the center of the axis back and forth like this. That is in general unlikely to happen. So n phi can have total values, n possible values from n minus 1 n to 1. That means total n values, n number of values, not excluding 0. It cannot have value 0. So according to Sommerfeld, in general, both orbits are following quantum numbers n equal to 1, n equal to 2, like that. But for Sommerfeld extension, including like this, for n equal to 1, there is no any elliptical orbit. Even for n phi, that means for there are elliptical orbits means there are also existing of n phi value. So here n phi also must be equal to 1. As we are decreasing n phi from 1, that means n phi must be equal to 0. So there is no other elliptical orbit for n equal to 1 value. For n equal to 2, this is the circular orbit. For this orbit, n equal to 2 and n phi equal to is also equal to 2. And here there could be one elliptical orbit for n equal to 2. That means here n phi must be equal to 1. So there is one elliptical orbit for n equal to 2. And again for n equal to 3, there are two more elliptical orbits, including the circular orbits. And in the same way, for n equal to 4, there are three elliptical orbits. Here for n equal to 3, here it is the n phi equal to 2. For the circular orbit, n phi is also equal to 3. Here n phi equal to 2, and for this elliptical orbit, n phi equal to 1. So in the same way, for the value, principal quantum number value n equal to 4, we can see 3 elliptical orbits. So there are elliptical orbits like this according to Sommerfeld theory. So but when we calculate the energy of electron when it is revolving in the elliptical orbits, can be calculated to be minus z square n e power 4 pi n 8 n is n square epsilon square h square. That means it is also inversely proportional to the square of the principal quantum number n, and it does not depend on the azimuthal quantum number n phi. And also we can see that the energies of electrons in the elliptical orbits also same as that of the energies of the electrons in the circular orbits, which is given by Bohr's atomic model. There is no deviation of energy values. That means we cannot explain the fine structure of spectral lines by taking the energy values like this, in this way. So, introduction of elliptical orbits has increased the number of orbits, but their energies being identical, the number of atomic energy levels has not increased. Therefore, additional electron transitions and spectral lines are not possible. If there are extra energy levels, then only we can expect more number of electronic transitions so that more number of spectral lines around those already existing spectral lines. It means that the concept of elliptical orbits only could not explain the fine structure of spectral lines. So that there is there should be one more consideration, that is relativistic correction. So according to Sommerfeld, he also considered the as the electron is revolving around the elliptical orbit, its velocity would not be uniform. So while the electron is revolving around the nucleus in particular elliptical orbits, as we discussed in the earlier slide, so the velocity must change as it is propagating along the elliptical orbit. So in general, if it is the nucleus, as the electron is revolving around the elliptical orbit, when the electron is nearby the nucleus, the velocity must be much higher than its velocity in circular orbit of the same energy. But when the electron is moving away, when it is away from the nucleus in the same elliptical orbit, its velocity is very less. Velocity decreases. Velocity is more when it is nearby the nucleus, when it is moving in this way. When it approaches the nucleus nearby, the velocity increases. Velocity of the electron increases, and it is moving away and it is very far from the nucleus, the velocity decreases. So this variation of velocity when it is moving in elliptical orbit causes for the relativistic correction of energy values. So such variations in velocity cause variation of the electron mass according to the theory of relativity. According to theory of relativity, as the electron velocity is comparable with the velocity of light, so mass of the electron also must vary with the velocity of electron. So as we consider the variation in the mass of electron, the energy values also changes because the energy values depends on the mass of the electron. So energy values directly proportional to the change of mass of the electron. Mass of the electron. So Sommerfeld showed that this assumption of the relativistic variation of the electron mass transforms the simple elliptical orbit into complicated curve known as Rosette, as shown in this diagram. So according to his proposal, electron revolves in elliptical orbits and the plane of the orbit also changes. So as the electron describes the elliptical path, the major axis of the ellipse revolves slowly in the plane of the ellipse around the nucleus located at the focus of the ellipse. After relativistic correction, The energy of the electron revolving around the elliptical orbit can be calculated to be n equal to minus mz square e power 4 by 8 n square h square epsilon r square into 1 plus alpha square z square by n into 1 by n pi minus 3 by 4n. So these are the energy values of the electrons when they are revolving around the elliptical orbits. So here there is a dependency of energy values on n pi and n. So as n pi value is changing, that means as the eccentricity of the ellipse of the orbit changes, the energy value also changes. And again, here alpha is the fine structure constant. So these are the energy values. So in this way, we can explain the fine structure of spectral lines. So there could be several uh, elliptical orbits for same principal quantum number, and thus there could be transition of electrons from higher energy levels to lower energy levels, including the elliptical orbits. That's why we are seeing the uh, fine structure for in every each and every spectral line. So, on observing energy values of fine structure of spectral light, it depends not only on the principal quantum number but also on the azimuthal quantum number n5, so that we are seeing the spectral lines. Okay, so at first sight it would seem that number of fine structure lines should be very large in view of the many possible values of n5. As the number principal quantum number n increases, the number of n5 values also increases, so that we can expect more number of spectral lines which are very close together. That is the starting observation at first sight. But Sommerfeld restricted the several number of spectral lines, that means fine structure lines, by considering the selection rule like this. That means delta n5 must be equal to plus or minus 1. So the transition from elliptical orbits must be with a difference of plus or minus 1. Then the number of fine structure lines decrease to limited number. Okay, so even though fine structure is explained by considering the elliptical orbits and relativistic correction, by considering the variation of electron mass. Sommerfeld theory of relativistic atom model could not explain the uh, he could not take the azimuthal quantum number values properly. Azimuthal later observations are that we can take the azimuthal quantum number m5 as zero also. Zero value also can be taken, so that azimuthal quantum number could be from 0 to n minus 1. Therefore, a new azimuthal quantum number L is introduced, where L equal to n pi minus 1. So that we are seeing in the earlier slide here, where we didn't describe the values of L in the earlier slide, but here these L values. Here L equal to 0, L equal to 1, but this L equal to 2. So that is also required to describe the elliptical orbits. So the new azimuthal quantum number L is defined as n5 minus. So Sommerfeld theory provided a theoretical justification to the existence of fine structure of spectral lines, but it failed in predicting the correct number of fine structure lines. It could not explain the correct number of fine structure lines. This theory could not give the information about the relative intensities of those spectral lines, how the intensity changes from each and every line to line. And Sommerfeld theory does not explain the distribution of arrangement of electrons in multi-electron atoms, as like Bohr's theory. Bohr's theory also could explain only single electron hydrogen atom or a single electron atom, any other atom also. So here also Sommerfeld theory could explain only single electron atom. It also could not explain the multi-electron atoms. So maybe you can see more improvements in the next lecture, that is vector atom model. Okay, so these are the reference books for this lecture, particularly a textbook of engineering physics by M.N. Avadhanulu and P.C. Kshirsagar. And these are also other textbooks to be referred for more clarity. Thank you all.
Like, share, and subscribe. Hit the bell icon for more updates.